Thanks everyone for joining today. Um, this is the November Water Conditions Monitoring Committee. My name is Emily Adrid and I'm with the CWCB. Um, Today, we have presentations from the Colorado Climate Center and NRCS. We are happy to have our NRCS partners back from the government shutdown. And so thanks just in advance to Brian for being with us today and providing updates, um, obviously along with Peter as well. Um, I have one announcement before we start. The 2026 WCMC meeting schedule is available online now, and I will put the link in the chat here um, just for your reference. But again, you can also find it on the WCMC website, which I will also put in the chat. So you can put those meetings on your calendar. And with that, I've seen some folks already doing this in the chat, but if you could please put your name and affiliation in the chat, that would be great. And I think that is all before we start. So I will pass it to Peter then.
All right, thanks, Emily. Good morning, everyone. Let's see here. All right, can you hear me and see my screen okay?
Yes.
Perfect. All right, good morning. My name is Peter Goebel. I'm the Assistant State Climatologist with the Colorado Climate Center at Colorado State University, and I'll be walking us through our climate conditions update for the November Water Conditions Monitoring Committee meeting. So we're going to start with just a quick update on recent temperature and precipitation conditions across the state, both the last month, last 3 months, and month to date. Then we'll do just a brief review of the previous water year, since we haven't met since the water year 2025 wrapped up. For those on the call who may not be familiar, a water year is just like a calendar year, but starts October 1st instead of January 1st. Much like the federal fiscal year. And the reason that we tend to track that here is because it more nicely follows our hydrologic cycle from the buildup of water resources through the cold season to the snowmelt and runoff season of the late spring and early summer, and then the growing season wrapping up around harvest time at the end of September. Then we'll do a quick look at some drought condition updates around the state, including looking at where we saw some significant improvements to drought, albeit in too fast a time frame with the flooding that we saw down in southwestern Colorado in places like Archuleta County. And then we'll look at what kind of seasonal forecast we may be on track for winter. And of course, as there always is, there's plenty of uncertainty when it comes to the seasonal forecast, but we'll look at what some of the ingredients are that might tilt things towards one way or the other. All right, recent conditions. So with these transition slides, I let AI make me some animations, and I guess the idea here is that we're gauging recent conditions, but here we go. All right, so we'll start with one of our quadrant charts. And here we are looking at statewide average temperature and accumulated precipitation conditions using the NOAA National Centers for Environmental Information NClimateGrid product. The horizontal axis shows you the amount of precipitation accumulated, and the vertical axis shows you average temperature. And if we look at the title at the top, this is looking at temperature and precipitation for the month of October. So we can see 2025 is well above kind of the crosshatch line you see running horizontally through the middle of the picture. That line shows what the average temperature, or the 1991 through 2020 normal temperature was. We were 2.8 Fahrenheit above that, and just a little bit above normal for precipitation, despite having a really major precipitation event in part of the state. A large chunk of the state was dry in October. Okay, this is how October temperatures differed from the 1991 through 2020 normals. So we can see that temperatures were above the 91 through 2020 normals everywhere, but on the west slopes closer to normal in that 0 to 2 degrees above normal range, 4 to 6 degrees above normal for much of the eastern plains, particularly in the Arkansas River Valley. And if we look at this as a kind of function of rank relative to the entire time series, here we're looking at how October 2025 ranked relative to the other 130 years on record going back to 1895, again using that NOAA Enclime grid product. And where we saw those warmer temperature anomalies in the Arkansas River Basin, that's where we were in the top 10 warmest Octobers on record, and some of the areas on the west slopes closer to historical averages. Here's how we are for the month of November to date. So no secret to anyone on the call, it's been a balmy November to date. We'll talk about how that may or may not change here in a little bit, but most of the state, at least 6 degrees above normal for the first half of the month, a pretty substantial temperature anomaly. I think as of right now, we're well on track for a top 10 November on record. However, like I mentioned, things may change over the second half of the month, and even some areas where we're 8 to 10 degrees above normal for the last 2 weeks or so. Okay, if we look at precipitation, here is precipitation percent of normal relative to that 91 through 2020 normal. You can see in our kind of 5-county area where the epicenter of our flooding event was in Mineral, Hinsdale, San Juan, La Plata, and Archuleta counties, we were well above normal, as much as over 200% of normal. And we'll look at ranks in just a second here. But then if we look east of the Continental Divide, or east of the Continental Divide and east of the Sangres, we can see that much of the eastern plains had less than 30% of normal precipitation. So certainly a big divide from west to east in precipitation in the month of October. And then this is how things ranked relative to that whole time series. Not actually the wettest October on record for the areas of southwest Colorado where we saw the flooding, although all that moisture was coming in just the span of about 5 days. We were top 10 in that area, I believe, up to top 2 in some cases. I'll have to do some double checking on that. And then if we look east of the Continental Divide, you can see some areas where, for instance, South Jefferson County and parts of Weld County, where we were bottom 10. Okay, this is month-to-date precipitation. The map is a little bit busy because it includes the U.S. Drought Monitor contours on it, but I want you to pay attention to the scale on the right-hand side that shows precipitation totals, and those are these filled-in contours. And the most important point on this map is that most of it is white. Most of the map has not, most of Colorado has not seen any precipitation for the month of November to date. And there are some areas that have had a little bit, even up to over half an inch, places like Cameron Pass and Rabbit Ears Pass, but even those places are below normal for the month to date. So across the entire state, we're off to a hot, dry start to November. All right, this is just backing up, zooming out a little bit to the last 3 full months. So this is August through October of 2025. 1.5 degrees above normal and above normal precipitation. So in that warm and wet quadrant is where you can see 2025. One thing that I haven't been pointing out as much recently is in terms of recent years, 2025 isn't way above normal. So, if you look up at 2024 was way above normal, and we can pick out other years like 2022, 2023, more recent that have been kind of on par, or in some cases even a little bit above what we saw in 25. I'll delve into that a little bit more with some of the water year numbers. Okay, this is how those temperatures compared to normal. I actually don't think this look is quite as informative as the rank map, so we'll go straight to the rank map here. And we see that for August through October, much of the west slopes was top 10 warm, and much of the Ark River Valley as well. some areas of central Colorado closer to long-term averages. All right, this is a look at the last 3 months of precipitation. The two big areas that stand out as wet are the Northeast Plains, where there's some really good moisture in August going into September. I think around mid-September, there was really good storm in there. And then, of course, Southwest Colorado, where we had the flooding, but then certainly some areas where we're below average too, like South Central Colorado. And then here's how this all ranks. So some areas where we've been top 10 wet or even record wet out in Phillips County, and then of course in Southwest Colorado as well. Most of the state, however, closer to historical averages. Okay, water year 2025, and here AI thought the animation should be water bottles as in a year of water use, but here we're going to be looking at temperature and precipitation statistics for the water year 2025, or October through September of October of 24 through September of 25. And we can see if we look at the entire water year here, we were in the warm and dry quadrant, pretty close to recent company, like 21, 22, 24. 23 was definitely cooler and wetter all the way down here. But we see we were a little bit, almost an inch below normal for precipitation, and 1 degree Fahrenheit above normal for the water year. Here is how things looked both spatially and temporally. So we're looking on the left-hand side at how the water year ranked across the state, and then the right-hand side shows how each month ranked in terms of temperature. So like I mentioned, this is last water year, so it starts October 24, not 25. October 24 was the warmest on record. Then we went cooler than normal for November with some major snows in eastern, especially southeastern Colorado. Very warm and dry again in December, and then some big cold snaps around MLK Day in January. Looking down towards summer, we can see, let's see, 17th for August, 23rd for June, 24th for July, out of that 130-year record. That's pretty normal for summer by recent standards. So if we look at the last 10 to 15 years, this summer would fit right in. And then just looking at things spatially, certainly west slopes much warmer than normal, Front Range urban corridor extending out up the eastern plains, top 10 warm, and then some areas throughout central Colorado where things were a little bit closer to historical averages. And then this is looking at temperature anomalies relative to the 1971 through 2000 average. I apologize for the mixed kind of reference periods here. So a lot of the slides so far have been 91 through 2020. The reason we're using 71 through 2000 here is if you look at this full historical record, we want to pick something a little closer to the middle, or most of the bars here will just look like long blue bars, well cooler than the 91 through 2020 average. But if we look at something a little more in the middle, 1971 through 2000, this is how temperatures compared to that average, which was, I believe, around 46.5 Fahrenheit. And we can see that this final bar represents 2025, about 2 degrees above that. And you can see that it, like I mentioned previously, keeps pretty good company with the last 10 to 15 years. So yes, it's well above historical averages. It's even above the most recent normals, but it's fairly right about in the middle of the range that we've seen over the last 10 to 15 years. A couple other things to point out on this map. So this kind of translucent gray line, that's a running 10-year average. The stippled yellow-orange line is the long-term temperature trend. And then the burgundy line is the trend since 1980. So you can see that line's a little steeper because the warming trend has accelerated in recent decades. This is a look at the same rank map and table that we saw for temperature, but for precipitation. We can see that it was a very dry water year on the west slopes in most cases. Again, this only goes through September 30th of 25, so that all that precipitation in southwest Colorado in October 25, not on this map, but we can see some areas of top 10 dry. We can also see some areas on the eastern plains, top 10 wet, certainly plenty of areas where it was top 20 wet. It was a nice kind of moist growing season for much of the eastern plains, whereas it was a below normal snow season out west with a dry spring and then a warm summer, warm and dry up to about the third week of August, where conditions started to turn. Okay, looking at things by month, I had mentioned November, we had a major snowstorm in southeastern Colorado, some areas getting more than their seasonal average snowfall in just one event. And then December, January, things turned dry. There were some areas where we got off to a really good start to the snowpack season, but then all of those kind of gains that we saw in early in the water year rapidly dissipated throughout the midwinter. April was 15th driest on record. I bring up April because this is actually our 8th drier than normal April in a row. And there's nothing in climate models to suggest that April in particular is getting drier. And so I think that's more a function of bad luck with natural climate variability. Hopefully we don't see a 9th drier than normal April in a row, because April's a really important month for our water supply. And then similar to temperature, here's the time series of precipitation anomalies relative to the 1971 through 2000 average. And this last bar represents 2025. And once again, yes, it's a bit below the historical average, but if we look at the most recent 15 years, it kind of blends right in there. So we've certainly had much larger dry anomalies like 2012, 2018, 2020. We had this 3-year stretch, 2020 through 2022, where every year was drier than we saw in 25. But then we've also had these years on the wetter side, like 19 and 2023. So lots of natural variability in the system here, but certainly we've seen more than our fair share of drought since 2000, and 2025 kind of fits in with that, but it was far from our worst one over the last 25 years. Okay, this just shows the amount of records tied and broken across the state using some of our longer term weather stations. So the table shows the amount of highest maximum daily temperature records in those first couple of columns, lowest maximum daily temperature, then highest minimum daily temperature, and lowest minimum daily temperature, followed by precipitation and snowfall records. You don't have to go through this table. I'm not going to go through this whole table, but there was about 1.9 warm records broken for every cool record broken. Okay, with that, we'll move into a quick update on drought conditions around the state, looking first at U.S. Drought Monitor, the current snapshot, and how things have changed over a couple of different timescales. We'll look at some standardized precipitation index maps. We'll talk a little bit about surface moisture, and then we'll talk a little bit about what we saw in southwestern Colorado over the last month. So here is our current snapshot of drought from the U.S. Drought Monitor. And so you see a lot of yellow on the map. That stands for D0, or abnormally dry. It's not technically drought yet. It's just marking conditions as drier than normal, potential early warning of a problem spot. And then we see plenty of moderate drought and even a fair bit of severe drought on the map. So 30% of the state is in moderate drought or worse. 13% of the state is in severe drought or worse, which, sounds bad, but in an average year, D2 represents the kind of bottom 10 percentile range of conditions. So you would expect in an average year, 10% of the state to be in severe to exceptional drought. And so we're not that far above that right at the current moment. And what you do see is the areas in severe drought are the areas where things got quite problematic going into summer, especially into the mid to late summer when we saw the wildfire season get really bad. Here's how things have changed over the last 12 weeks. So for the most part, things were worse on the U.S. Drought Monitor 12 weeks ago, especially on the west slopes. We've seen improvements starting about the third week of August, with some better moisture coming into western Colorado, and then major improvements that second week of October in southwestern Colorado. But we've also seen with some of the previous maps that we've been dry in eastern Colorado, and so we are starting to see more degradations pop up east of the Continental Divide. In particular, you're seeing a lot of D0 starting to pop up. And then this is how things compare to a snapshot 1 year ago. So most of the west slopes was showing less drought or no drought a year ago at this time. And eastern Colorado, in a lot of places, especially north central Colorado, things looked worse on the US Drought Monitor this time 1 year ago. I'm just going to show standardized precipitation indices from a couple of key timescales. These data come from the PRISM Climate Group. And standardized precipitation index, the reason we look at this metric is because it gives us a good idea of how rare it is for conditions to be either as wet as they are or as dry as they are. So basically the legend there is showing what the SPI is. It's showing kind of how many standard deviations above or below normal precipitation is. That's a little bit of an oversimplification, but I'm not going to get into the whole curve fitting aspect of this. What you need to know is that the areas in white are areas where precipitation has been pretty near normal. Areas in green are where it's been wetter than normal, and then areas in blue and purple are where it's rare to be this much wetter than normal for the last 60 days. And then areas in yellows and kind of that tan color are where it's been drier than normal. And then where we see the oranges and reds, and especially dark red, are where it's rare to be that much drier than normal. So that's 60 days, but this is approximately the last year or 360 days, where we can see even with some of the recent moisture out west, there is still definitely long-term drought lingering west of the Continental Divide, particularly picking out places like western Eagle County, Pitkin County, and then let's see, that would be eastern Garfield County and Mesa County. And then there are areas, like I mentioned, where it was a nice wet growing season east of the Continental Divide. So how has our surface water responded to all this? So this is looking at a representation of soil moisture in the top meter of ground, so the meter of ground closest to the surface. The key on the right-hand side will show you the percentile range corresponding to each color. Again, where it's white, that is reflective of conditions in the normal range. Where you see the bright colors, the warm colors, are where it's drier than normal. Cool colors, wetter than normal. A couple take-home points here. So this time of year, people are often looking at soil moisture, particularly in the mid to high elevations of the west slopes, because if you have wetter than normal antecedent soil moisture conditions, then when your snow melts in the spring, less of that snow melt would have to go into recharging soils and more of it could go into runoff, lakes, streams, and reservoirs. Conversely, if soils are dry, you may lose some of that snow melt to recharging the soils. And for the most part, what we see is a little bit more optimistic picture than we've seen in recent years. So I'm curious how that's going to affect things. I should also say very clearly that we still need a good snow year to have a good runoff year. This is not something that's going to make the runoff year in and of itself, far from it. So we still do need a good snow year, and we're off to a very slow start. But this may help things a little bit come springtime, unless you're in some of these areas where we see drier than normal soils like Eagle County and again, eastern Garfield County, Grand County. I should also mention that with soil moisture, local conditions vary. So the representation that you're seeing here from this model may not be reflective of any given individual field. And then this is a look at terrestrial water storage. So this is, again, from that NASA Western Land Data Assimilation System suite of products. And what terrestrial water storage is it's a modeled integration of soil moisture, groundwater, snowpack, and canopy moisture, which canopy moisture for most of Colorado is negligible or non-existent. Soil moisture is an important component of this time of year, but then groundwater is probably the biggest component of this product this time of year. Snowpack is also a very big component of this product as you get later into the snow season, but this product has been tracking kind of long-term declines in groundwater. And again, local conditions may vary. It's not going to get everything right from every individual well, but we can see across much of eastern Colorado, drier than normal or drier than kind of those long-term. I guess this product goes back to the 70s, but drier than normal terrestrial water storage. And that's been kind of, it does wiggle up and down, but there's been a long-term trend towards lower terrestrial water storage. Okay, just a couple slides here on the flooding event that we saw in southwestern Colorado. For more in-depth information on this, you can visit our website. We wrote a blog piece about it. We also wrote a blog piece and did a water year summary if you want more in-depth information on the water year slides that I was showing earlier. But this is a look at some of the precipitation totals across the state, or across the southwest portion of the state from October 9th through 15th, where we saw some areas in excess of 10 inches of precipitation in Mineral and Hinsdale counties, kind of up near the headwaters of the Rio Grande, but also the headwaters of the San Juan River Basin. And so some really major precipitation totals within just 1 week there. The most comparable flood on record, we have to go back to 1911. And those are similar events in the sense that they were both caused by remnant moisture from tropical systems. So this was kind of a 1-2 punch of remnant moisture from Hurricane Priscilla and Tropical Storm Raymond in the eastern Pacific Basin. And of course, these were not hurricanes or tropical storms by any means when they hit Colorado, but it was these large slugs of moisture that spun out from these storms and rained over the southwest portion of our state in large volumes. And along with that, we did see major flooding, including 2 times the San Juan River near Pagosa Springs reached major flood stage. I opened the presentation with an image from the Colorado Sun that showed the showed the San Juan River through Pagosa Springs, getting up to the banks of the hot springs. And I think that it did at least partially inundate the hot springs in that first kind of wave. So that's what I have for current conditions, recent conditions, water year to date, and drought update. Now we'll get into the winter outlook. So it doesn't feel like winter. It doesn't feel like winter's around the corner, other than the fact that our days are now really short. It's certainly been a balmy November, but the next couple of weeks, things could really change. And then we get into our true winter season, and we'll talk about how La Nina impacts that. So this is a map showing the NOAA Weather Prediction Center's 7-day precipitation departure from normal forecast. Areas that are shown in the brown colors are where below normal precipitation is forecast. The blue-greens are where we have above normal precipitation forecast. And as you can see, for most of eastern Colorado, we have a forecast for above normal precipitation, largely due to a storm system that's going to start to make its way into the state tomorrow night, starting with southwestern Colorado, but then tracking across the divide kind of into Thursday morning. I think that last I looked, the main impacts for the metro area, as well as most of Colorado north of the Palmer Divide, were for Thursday evening. And so it'll be interesting to see how much moisture we get out of this one. We're certainly due for some moisture. And at least some of this will be snow. Not exactly sure where the rain snow line will be with this one, because it is a little bit more of a warm core storm than we typically see for this time of year. So for some of us, this could start as rain, could be kind of a rain snow mix turning over to snow in the evening hours. But I do expect that certainly for higher elevations and mid elevations, this will be snow. And then as we get into the 8 to 14 day outlook, it's looking like weather models are leaning towards this being an active time frame as well over that Thanksgiving week. with an increased probability of below normal temperatures for most of the state, particularly as you look towards the northwestern portion of the state, and an increased probability of above normal precipitation across the state, particularly for northern Colorado. So very different conditions than what we've seen so far. I think it'll be kind of our first true taste of more wintry weather, and probably feel like a bit of a rude awakening with this really balmy autumn that we've been enjoying so far. But we certainly, as we all know on this call, need the moisture. It looks like this storm, kind of around Thanksgiving, there's potential for a snowstorm that's more of a cold core storm dropping out of the northwest that I expect temperatures to be definitely lower than the one this week, and we could see more of like a true all snow event next week. So we'll see how that all plays out at lower elevations. So if we kind of integrate the last two slides, this is a graphic that shows the number of forecast models out of a model ensemble that are predicting at least 1/10 of an inch above normal moisture over the middle of November through early December timeframe. And very unlike the first half of the month, where like we saw earlier, there has been very little precipitation across the state. It's looking like most of the state is favored for above normal moisture over the next couple of weeks. And as I mentioned earlier, it'll definitely be a change in terms of temperatures as well. So the phraseology I like to use when we get beyond 14 days is when we get beyond 14 days, those numerical weather models that we've looked at over the last couple slides descend into chaos. And so the only way to really gain predictive skill on a seasonal time scale is to look at more statistical relationships between what the atmosphere does and how it behaves and other slower moving portions of the climate system. And oftentimes when we talk about this, we're talking about El Nino or La Nina. El Nino refers to a sea surface temperature pattern where you have warmer than normal waters over the eastern equatorial Pacific Ocean. La Nina is the opposite, where we have cooler than normal waters. This graphic is showing sea surface temperatures across the globe in mid-November, and we can see that those cooler than normal waters are coming into play over the eastern and central Pacific. Why this matters is it affects the tropical trade winds, which in turn, through something called conservation of angular momentum, impacts the jet stream in the northern hemisphere, which is the high altitude current of air that controls the movement of our high and low pressure systems that brings us our storms or lack thereof. So there will not be a quiz, but the long story short is that El Nino has an influence on the weather that we experience in Colorado, or La Nina in this case. This is a correlation analysis showing how El Nino versus La Nina tends to impact precipitation in Colorado. The upper left-hand panel is showing the relationship between El Nino versus La Nina and precipitation in December, January, February. Upper right is spring, March, April, May. Lower left is summer, lower right is fall. Areas that are in red are areas that tend to be wetter during El Nino. Areas that are in blue are areas that tend to be wetter during La Nina. You can see for the most part across the state, El Nino is kind of preferred for wetter conditions. The one exception is the northern and central Rockies in La Nina, which is the season that in the season that we're about to start. And the forecast for La Nina indicates that it may fizzle by spring, which in a sense is the best of both worlds, where La Nina favors more precipitation in the northern Rockies during winter, but by the time spring comes around, we don't necessarily want it around anymore. One thing that I should also mention along with this is that there's tons of uncertainty when it comes to seasonal forecasting. And so using these kinds of statistical relationships, it's like playing poker with a couple extra aces and kings in the deck. You may have an idea of how things are tilted compared to normal, but you could still draw a really crummy hand. This is a look at the International Research Institutes and so forecast. The blue bars show the probability of La Nina by season. The red bars, El Nino, the gray bars, neutral conditions. And the long and short of this is that we are in a weak La Nina now, and it's likely to fizzle by sometime around late winter, early spring, which, like I mentioned, that's kind of best of both worlds for us. So that's about the time frame when we would want it to fizzle. But again, this is there's a lot of noise to muddy this signal. Okay, seasonal temperature and precipitation outlooks. These are from the Climate Prediction Center. The graphic on the left-hand side shows you the probabilistic temperature forecast across the contiguous US for December through February. On the right-hand side, we're looking at precipitation. For temperature, where you see those oranges and reds is where there's an increased probability of above normal temperatures. The blues are where there's an increased probability of below normal temperatures. Similarly, on the right-hand side, browns are where you have an increased probability of below normal precipitation, and the greens are where you have an increased probability of above normal precipitation. And right now, the CPC is showing a very quintessential La Nina pattern. However, if we look at Colorado, we're kind of right in the middle there, where it shows equal chances for precipitation, or as we like to call it, equally clueless. I'm a little bit more optimistic than this for the northern and central Rockies, for the reason that the CPC tends to paint with broad strokes, and they don't necessarily do justice to elevational gradients that may exist in some of these precipitation forecasts. Where for December through February, I'm a little bit more optimistic towards perhaps a little bit of an increased probability of above normal precipitation. As you get towards the southwest corner of the state, though, things look a little bit more bearish. And then for the left-hand side of the page, where we're looking at temperature forecasts, yes, there's a slight tilt towards above normal temperatures for southwestern Colorado. La Nina, if anything, tends to be associated with cooler temperatures in winter, especially as you get towards the northeast end of the state. The reason that we don't see that clearly in this graphic is because the signal that we have from La Nina is more than outweighed by the signal of our long-term climate trends towards warmer temperatures in all seasons. And so I think if it was an El Nino year in winter, you would be seeing this increased chance of above normal temperatures showing across the entire state rather than just part of it. All right, so that's all I have, just a couple of takeaways. Been balmy autumn thus far, even by recent standards. Let's see, last month was about just a little under 3 degrees Fahrenheit warmer than our 1991 through 2020 normal in November to date. We've been 6 to 8, in some cases 8 to 10 degrees Fahrenheit above normal. Water year 2025, we landed a little bit in the warm and dry quadrant by historical standards, or a little warmer and drier than normal. But by recent standards, it was kind of right in line with what we've been seeing. We talked about the major flooding that we saw from remnant tropical moisture in southwestern Colorado, and we've had a couple other precipitation events that have improved drought conditions in western Colorado. But with some short-term dry conditions creeping back in east of the Continental Divide, we're starting to see drought creep back into the picture on the Eastern Plains. Rest of the month is shaping up to be more active. Hopefully, we'll start to actually see some winter around here. And then we do have a weak La Nina in play right now, right? And models suggest that it may not stick around all that long, but La Nina tends to tilt odds towards snowier winters in the northern Rockies. So we're rooting for that, especially given the fact that we're already behind on snowpack early in the season. So I will go ahead and wrap things up there. Feel free to get in touch with us if you have questions, or ask them unmute or ask in the chat, whatever works.
Thank you, Peter. Thanks for providing both the short-term look at drought with the U.S. Drought Monitor, and then more longer-term looks at drought with the SPI maps that you provided. I think having both the short and long-term is important for planning Um, I do have one question, and maybe you might not have a good answer, but do you think that the warm and dry conditions that we've experienced and the degree of warmth and dryness, um, is this kind of a preview into what normal conditions for this time of year, late fall, will look like in the coming decades with a changing climate? Or is
Yeah,
that
really
not
good
something you
question.
can
So,
confirm?
certainly we do expect the long-term trends to continue upward, and the degree to which that's true is dependent on our kind of emissions pathway.
Right.
However, there's definitely a natural variability component to this in that right now, temperature anomalies across the state for the month of November to date, 6 to 10 degrees above normal. That's way warmer than normal. And so I don't expect averages for this time of year to get there anytime soon. Probably not within my lifetime. However, the years when we see these kind of similar weather patterns where we have this high pressure across the western US and these more stagnant weather patterns, like the balmy falls that we do get will be even balmier, but we'll still have the falls that are wetter than normal, where we get more cold fronts, more activities, and like I mentioned, we're certainly going to see a change in the next couple weeks. But yeah, um, good question.
Yeah, thanks for taking it. Um, any other questions for Peter? Well, if a question does come up, just feel free to put it in the chat. And I think we'll pass it over to Brian now.
Yeah, good morning. Thank you, Emily, and thank you for the very warm welcome back. It is
Yeah,
good to be back in the swing of things. So thanks.
absolutely.
Peter, I was ready for the quiz, but I guess maybe next time. And I also want to say thank you for your optimistic outlook. That does look promising, truly. I hope we do wind up getting some precipitation and snow here in the very near future, because as you pointed out earlier, we are running pretty low. So let me pull up the presentation here, get it started. I'll share my screen. Forgive me. Let's try to share. All right, let me know if you can see the presentation.
No, we're looking at your email.
You're still looking at the email?
Yeah.
Okay, let me try to undo that. I don't know why I always have. Hmm, Try one more time. All right, how about that? Is that any better? Seeing the
It's
presentation?
it's loading. Oh, yeah. That's good to go.
Okay, is that the presenter slide or is it the main
Uh,
presentation?
it's the main presentation.
Okay, perfect. Thank you. And
Yeah.
sorry for that delay there. All right, so getting started, Peter really drew out a lot of the bigger take-home points here. I'm going to focus more on the mountain conditions and the snowpack that we're seeing, as well as kind of some soil moisture conditions, reservoirs, and stream flows. And just like Peter, I would also like to kind of wrap up the 2025 water year, since this is the first time that we've met since September 30th, as he mentioned, when the water year ends. So we'll just kind of go back a little bit further, all the way back to last winter, because it does kind of have implications on our fall conditions, which in turn, as Peter mentioned, has effects on 2026 runoff implications. So last year's snowpack peaked on April 7th at 89% of median, a little bit below normal. We would like to see those numbers a little bit higher there, but you know, we wound up seeing warmer than normal conditions through spring, which allowed that snowpack to melt earlier than normal, although the melt out was near about normal because of some of continuous storms through the spring. We still wound up seeing that hydrograph being lower than normal, the runoff being lower than normal because of the below normal snowpack peak and because of the earlier than normal melt, those warm temperatures that we saw. So where did the water year for the mountainous sites, data collection sites that we manage, wind up? That water year wound up at 87% of median. And for the graphics from here on out, 2025 will be indicated by either a blue or a blue dotted line, depending on the data type that I'm displaying. Median here, as is the case for most of these types of graphics, are the green line here. So median's kind of right in the middle of the observations. And in this case, last year's water year-end closeout on September 30th wound up being 87% of the median for the entire state of Colorado. Now, as we all know, Colorado is a rather large state, and the conditions that we saw, that one number, 87%, is not necessarily the best representation of what went on everywhere. So let's dive in a little bit. Looking at the west side of the state, the median year-end precipitation wound up being a little bit below normal. So your Gunnison, Colorado, combined Yampa White, and the San Miguel, Dolores Animas, San Juans were all about between 80 and 85% of normal. Going east of the divide, things were a little bit better, near 90 to 95% of normal, with the exception of the Upper Rio Grande, which was about 83% of normal. For some reason, there seemed to be a little bit of a data issue here. I need to dive in a little bit deeper, but I don't trust this 101 number so much as I believe it to be 95% of median is where the water year ended on September 30th in the Arkansas. Looking at the time series graphs, I wanted to highlight kind of the two most extreme basins in the state for year-to-date, or excuse me, for water year 25 precipitation. Highlighting the Arkansas at 95% of median, you see we were there in the top 30 percentile, but still not quite at median. And then looking at the Upper San Juan Basin, where things were quite dry, we wound up being at 78% of median is what that previous map showed. So pretty dry conditions. It was right at about that bottom 10th percentile for the San Juan Basin. Okay, so that's how last year wound up. Still a bit on the drier side, from snowpack to year-end precipitation to even soil moisture. I didn't highlight soil moisture here, but I'll show where soil moisture is at as of yesterday. So as of right now, snowpack across the entire state of Colorado is 25% of median. Now, as is typically the case, if you join these meetings, you know that I prepare the presentation usually the previous day. And that's what I did for almost this entire presentation. And as of yesterday, snowpack was at 25% of median across the entire state. I did look at what the number was this morning, and it did indicate a slight improvement at 30% of median. But the data has yet to be reviewed this morning when I put this I got that last piece of information. So, but really that's not much of a change, 25 to 30%. It's an improvement, I'll take it, but we're looking for a little bit better improvement than that. Going around the state, the Arkansas, as of yesterday, data from yesterday was 20% of median snowpack. The Yampa White, Little Snake, and North Platte were all 24% of median. South Platte 25, Gunnison 25, and then the San Miguel, Dolores, Animas, San Juan is 33%, and the Upper Rio Grande 29. So yeah, we're looking pretty low. Even with that bump up to 30% of median, I was seeing that snowpack is still in the bottom 10th percentile for snowpack. So we really need an improvement. That's why I was finding Peter's outlook to be very encouraging. I know we're not supposed to rest or hang our hat on it too hard, but it is encouraging. If it's any consolation at all, zooming out across the Western United States, snowpack really isn't much better anywhere else. While we are pretty bad in terms of snowpack here, it's looking pretty abysmal across the rest of the Western United States. And I'm not putting too much stock in what these conditions that we're seeing in Arizona and a little bit of New Mexico. I need to dig deeper into that data. Last I checked, they were still running pretty low for snowpack, but it might be more of a numerical anomaly than anything. Just a little bit of snow at a few sites can make a big difference. So I don't think that this is of any real significance at this point. So much of the rest of the Western United States is showing pretty poor snowpack as well. Moving on into precipitation, still looking at the Western United States, things wind up looking much better in terms of the total precipitation to this point in the year across much of the Western United States. And now we'll zoom in to Colorado here. Things do look a bit worse for total accumulated precipitation. This is through yesterday morning, all the data accumulation here. As Peter pointed out, northern Colorado and portions of central Colorado, low precipitation accumulation to this point. Things are looking a bit better simply because of that storm, the storm in central October or middle of October, excuse me, from about the 10th through the 16th. But that's really the main factor that boosted the numbers down here. And I'll kind of break that down here in another slide or two. So I wanted to dive into the precipitation event. Peter already did this as well. The numbers are almost exactly the same that he was showing here. Much of the San Juans in that event that happened, I encompassed October 9th through the 16th. We saw a little bit of precipitation on the 9th and a little bit on the 16th before things really started to dry out on either side of that storm. So we saw some significant numbers here, 10 inches at the Upper San Juan SNOTEL, and then a number of SNOTEL sites that got upwards of 9 inches of precipitation through that 7-day period. In this next slide, I'm trying to show kind of the extreme, for lack of a better term, of that event. And I'm here just showing the percentile of the event from the 9th through the 16th for that time frame. Okay, I'm not extrapolating out or looking at that precipitation event against all other precipitation events at any portion of the year, simply that particular, those dates, the 9th through the 16th. And you can see that any of those sites that have a 100 denoted by it, that was the maximum amount of precip for that time frame in the period of record for our SNOTEL sites. So Peter and the Climate Center's data for those sites that they have, some of them have a longer period of record. I believe that some of the sites that were also on his map were also SNOTEL sites as well. Our period of record for SNOTEL sites range from usually 45 down to 25 or 30 or 25 or 15 years, depending. But all of this data that's being shown here is all SNOTEL sites, and you can see the vast majority of them did receive the largest amount of rain for that period. Or I should say precipitation, not rain. A few sites did receive snow, but it actually was rain in most locations. But outside of that event, things have been pretty dry. The graphic in the upper left is precipitation for month to date, November 1st through the 16th, and you can see it's been quite low. And then expanding that time period all the way back to right after the precipitation event, October 18th through November 16th. Again, quite low. I'm sorry I didn't put any of the actual numbers or percent of median here, but nonetheless, you can tell by the color red and orange that precipitation has been rather low. Going over to the time series graph and actually looking at the entire statewide precipitation year-to-date number is actually 92% of median for our SNOTEL locations. And this graphic isn't exactly the best representation of it, but you can see that event here. This is the entire state of Colorado. The black line is this year's precipitation accumulation. Got a pretty sizable bump here. I think it was about 2.3 inches for the numbers that were received across the entire state during that mid-October storm. And let's move into the Upper San Juan, which saw the biggest impacts from this event. You can see, I think it was about 7 inches of precip that averaged out in that mid-October event. And as of yesterday morning, year-to-date precipitation was 179% of median in the San Juan. I'm going to go back one slide, back to the state of Colorado. I did some kind of back of the napkin math here, and I wouldn't necessarily quote me on it, but I think it is worth pointing out that if we remove all of the precipitation across the state for this event here, the mid-October event, our precipitation to date would then be 40% of median, or 40 to 50% of median. So just wanted to highlight how impactful that event was. Had we not had it, even in the kind of isolated location that it did happen, our numbers across the state would likely be much lower. Now, the scenario that I just kind of laid out there is probably would not have happened that way. We've gotten some amount of precip through that period. So maybe it wouldn't have been that low, but I think it is, I thought it was noteworthy that it is a big shift had we not received that event, even in the limited location that it was in. Okay, I just advanced forward 2 slides. We'll look at, I think, 2 more basins here. I wanted to show the South Platte Basin water year-to-date precipitation because it is, I think, the basin in the state with the lowest accumulated precipitation to date. That's at 53% of median as of yesterday morning, or excuse me, as of this morning. This is the only graphic where I pulled up data for this morning. So the South Platte is the basin that has the lowest precipitation, as I recall. Oh, and I'm sorry, I don't have any other time series precipitation graphics. Showing soil moisture here. As I always point out here, soil moisture, take it with a grain of salt for a number of reasons. One, the period of record is not very long for the sites that we do have soil moisture sensors at. And the number of sites at which we have soil moisture is relatively limited. But it does kind of give a general idea of the conditions that we're seeing. I think as well as, I think it's worthy or worthwhile to also pair other information, other data sources, such as the graphic that Peter showed, that WL-DAS product, just to kind of get an idea of where soil moisture is at. So this first map I'm showing is the 8-inch soil moisture sensor. The next map I'm going to show is the 20-inch depth soil moisture sensor. And so, putting all those things together, we kind of start to get an idea of where soil moisture is at. The 8-inch soil moisture sensor, being not as deep, is a little bit more variable, a little less stable, but by nature that is the case. It's more susceptible to aridity and also precipitation events. So as we're looking at this map, I'm starting to see that the north and western portions of the state are seeing slightly better soil moisture, at least at the 8-inch sensor. Not too surprising there. I am a bit surprised that the Upper San Juan is showing such dry conditions, but again, we only have, it looks like 2 sites. So I'm really not super surprised there. Plus, it has been a while since that storm. It's been, what is that, over a month or just about a month since the storm in October. So wouldn't be too surprised if we saw some of that aridity. But as Peter's map showed, there is still a fair amount of soil moisture there. And then looking further east where things have been a bit drier, we're seeing drier soil conditions at the 8-inch. Moving into the 20 here, not too surprised to see that things are a little bit more consistent, drier up north, a little bit more wet south and central. But that sensor is sometimes a little bit more stable and can carry more moisture when things are a bit dry like they have been across much of the state. So again, take it with a grain of salt, but it does, I think, provide at least an indicator of what we're seeing in conjunction with other products out there. All right, last two data types, reservoirs. Reservoir storage as of November 1st, when we last collected the data. And I wanted to say a huge thanks to our team here for collecting all this data in a relatively short period of time to get all this reservoir data updated. Statewide reservoirs are at 84% of median as of November 1. That's up 4% where from last month, October 1. Where there was a slight improvement. This time of year, I don't hang my hat too hard on this information just because it is fall and reservoirs are typically drained down this time of year because irrigation season is pretty much over. And then looking at time series of, I just simply decided to highlight the Gunnison and the San Miguel de Loras Animas San Juans because they are some of the larger accumulated or total reservoir storage basins in the state. Some of these other, if I were to turn them on, or if you were to turn them on our website, you'll find that it's very hard to see changes. The amount of storage in those basins is quite small. And I think you can see over here on the right side that reservoir storage has ticked up a few percentage points to be specific, in the last month. All right, stream flow. I like to show these again, as Peter mentioned, to highlight how conditions are going into fall, because fall conditions, particularly in soil moisture, can be a pretty good indicator of how thirsty the soils are come spring when the snowpack starts to melt off. And stream flows are, I think, in most cases are a relatively good indicator of where overall soil moisture is at, or just base stream flows are at, as we tend to lead in when runoff does wind up happening. Thought I'd start off with the San Juan River here at Caracas, highlighting, at least it's hard not to see the large spike from the mid-October storm. But since then, things, the hydrograph has subsided quite quickly. Median stream flow is indicated by the green dotted line. I hope it's easy enough.
Uh-oh. Think we lost Brian.
Am I back?
Oh, yep.
Sorry about that. I have no idea what happened. It seems like Zoom quit and then came back.
Oh, weird. Your audio was cutting out a little bit before that, so.
Oh, we've had connectivity issues here at the office.
Okay.
Let's see, can I get right back into it? Are you seeing the presenters or the main slideshow?
Yep.
Okay, perfect. Well, hopefully that doesn't happen again. I just have a few more slides and then we'll be done. So to me, the recession of this hydrograph really shows how dry things have been since, to go from such a high peak right back down to just about median in such a short time frame is pretty, I shouldn't say rare, but it's kind of quick to see how quickly that subsided right back to the median. And moving on to, I just decided to pick a few basins in the state just to show how stream flow conditions are. Colorado River near Dot Cerro might be hard for you to see, but the black dotted line, which of course is 2026 at this point, is below the median line. So running relatively low there. Gunnison River near Gunnison is also indicating slightly below normal stream runoff right now. Yampa River near Maybell looks like it's right at or slightly below median stream flows. Arkansas River at Salida is also indicating slightly below normal stream flows. And I didn't put it in the presentation, but I happened to look at the South Platte, which is running slightly above normal. But as far as I know, I think a lot of the stream flows in the South Platte are regulated flows or man-made flows. So I don't think they're extremely natural and may not be much of an indicator as to exactly where soil moisture conditions sit at this point. So that's the last of the data slides. In summary, snowpack is well below normal. We're going to need a lot of, I shouldn't say a lot, but we definitely need precipitation at this time, and hopefully it comes in the form of snow, and hopefully it is above normal. Statewide precipitation is at 92% of median, and largely because of the mid-October storm in the San Juans. Statewide reservoir storage is up to 84% from 80% last month, and soil moisture conditions, I would argue, are running a little bit below normal in the mountains. We did see some good information from Peter that perhaps in the San Juan conditions are a bit better, but I think it warrants continued monitoring and watching the entire state as well as just the San Juan, that probably soil moisture conditions are a little bit below normal. And I think the real take home point is we need more precip at this point. So my fingers are crossed. That's all that I got.
Awesome. Thank you, Brian. Any questions for Brian? Well, again, thanks for being with us, Brian, and we're happy to have you back. Yeah, I guess take home message. Oh yeah, Swithin, saw you come off mute.
I was just looking at the agenda coming up. That's
Okay. Yeah, I think just take home message from both presentations is we need precipitation, and hopefully we'll get some in some areas of the state over the next couple of weeks. So yes, Swithin is ahead of the game. I'd love to hear from water providers, water managers, to hear what the local conditions are like in your state. So Swithin, do you want to kick us off?
sure, since I got caught jumping the gun. So for Brian, you are correct on the South Platte flows are pretty much all regulated. It really isn't. A lot of work is needed to tease out what the natural flow is versus deliveries from reservoirs or the west slope. Kind of a quick way to judge where things are in South Platte is the upper South Platte down to just where the river comes out of the mountains and the hogbacks. Call there is in the 1890s. So that's fairly senior for this time of year. Overall, for Highlands Ranch, where I'm at, things are very warm and dry, as Peter indicated, and our area is marked since late August as being in moderate drought. I would agree with that. Our irrigation season started about 3 weeks early in April than normal and extended to the last week of October. Overall, our water use our irrigation season use was about 10 to 15% above normal. Overall, our water use for the year is at 105% of normal. Luckily, we did get some temperatures in the 20s there around last Sunday in October, and shut everybody's irrigation systems off. So that has helped. Just wanted to say that as far as the non-irrigated areas, the natural lands, we are seeing desiccation cracks in those areas. So if that's helpful for Peter. And so our reservoir storage is at 54% of capacity, but it is November and irrigation season's over, so that is good. And in the tradition of the Nolan Deskin legacy, the garden update is I've still got lettuce, carrots, and beets growing in the garden, requiring water. So that is a very late into the growing season along the Front Range.
Wow. Love to hear that.
It's nice, but it's wrong.
Yes, yeah, it's nice, but it's wrong. Thanks, Swithin, for the comprehensive update. Who's next? Hey, John.
Howdy, I'll go next. Thornton's consumption year to date is, oh, I can hardly see it. 3.63% below last year. So you know, our customers have done a good job all year long, at least compared to last year. Storage is sitting at 90-some percent, 93% a couple of weeks ago. And we're in really good shape going into the snow accumulation season if it would just start. So, and we are in drought watch because there is drought present in our watersheds, all three. And so that is indicated by our drought management plan to be in drought watch. I'll let you know in a couple of months whether we're going to have drought restrictions.
Great. Look forward to it. Thanks, John.
Hi,
Who's next? Hi.
this is Melissa Owens with Aurora Water. I don't have a big update, but I know as of 11/9, we are at 66% of our storage. And as far as drought restrictions, it's still too early for us to know yet. But, you know, or I know we're seeing similar things that everyone else is seeing. But that's pretty much all I have.
Thanks, Melissa.
You're welcome.
Hey, good morning. This is Ethan Brava with Colorado Springs Utilities. As of November 9th, system-wide is about 77% of capacity. Our consumption is slightly higher. The year to date, it's about 8% higher than last year. And we are just running normal winter operations in our reservoirs. Thanks.
Okay, great. Thank you.
Hi, I'm Beverly Richards with the Upper Gunnison Basin. We got a slight bump in our snow water equivalent this past week. We went from 19% to 36% because we got some snow up high in Crested Butte. The precipitation amount for the Upper Gunnison Basin is at 96%, and that's remnant of the October events that we had in part of our basin. So that was in Hinsdale County. And reservoir storage for the basin is 54%. But that's not too bad going into next year, hopefully.
Thank you, Beverly. Yeah, go ahead, Adrian.
Hi, everyone. Adrian Berger, San Miguel Watershed Coalition. My update is that we have a new surprise SNOTEL site. I'm sure it wasn't a surprise to everyone, but it was a surprise to me to see it come online in Alta Lakes Basin, which is sort of like on the other side of the Telluride Ski Resort to the south. That's great because we only had a few SNOTEL sites in the basin, and most of the sites that are used to determine our SWE are actually just outside of the watershed. So really great to have another site, especially one that is more representative of the ski area for those rec users. Similar to the Gunnison, it finally snowed. The trails are finally non-walkable or rideable anymore. Pretty late for that, but previously no snow around here, or it had melted off. Thank you.
Yeah, awesome about your new SNOTEL site. Thanks for some Southwest updates as well. Anyone else want to go?
I can give a Denver water update.
Yeah.
We're at 83% of storage, compared to 89% of normal, for us this time of year. So, below normal, but slow start. We're keeping an eye on things. Similar to everybody else, long way to go.
Yeah.
But lower than normal. Our use is about 4% higher year to date, than normal. So down from last year, but a little higher than average.
Thanks, Ryan. All right. Last call. All right, I think we can close out for today. Thank you, everybody, for providing your updates. Really appreciate that. And thank you again to Brian and Peter for your presentations. The presentations and meeting recording, along with the meeting summary, will be on the WCMC website by the end of this week. And with that, I wish everyone a happy holiday season. And I will see you all in 2026 on Thursday, January 22nd. So thank you, everybody.
Yeah, thank you, Emily. Thank you all.
Thanks.
Happy holidays.